Hi class, so I made this example for you to complement the written example. This is for the week 2 discussion, and so we have two inequalities to solve. This is the first one. This is a compound inequality, and so what you're trying to do is you're trying to isolate the x here in the middle. Let me highlight it here in blue maybe for just 1 second. So what I need to do is I need to move the 5 over and then the 3. Now, when you do an operation to move a number, this 5, I want to move it over, so I need to subtract 5. So what you want to do is you want to treat this like if it's two equations in one. So you're going to subtract 5 on the left side, and then you're also going to subtract 5 on the right side. So then what you end up with is negative 12 is less than or equal to 3x, which is then less than or equal to 15. Okay, now to move the 3 over, since it's multiplying, you're going to divide by 3 on the left and the right side. And so now what you get is you end up with x, which is less than or equal to 15 over 3, which is 5. But greater than or equal to negative 4. So this is what your solution is. Now, if you want to write this in interval notation, then what you would do, I would write it in graphical notation first, actually, and you'll see why in a minute. So let's say I write down, I put my graph here. And I have negative 4 here and then 5 here. So where's my solution? Well, it says that x is greater than or equal to negative 4, but less than or equal to 5. So that's describing this area right here in between. So I'm going to highlight that. And now, since I'm including both, and that's what this line means, that it's equal, less than or equal to, that means that it's including the numbers negative 4 and 5. So that means that they both would have brackets. Now, if that equality was missing, then you would use parentheses. But since it's included, then we would use brackets. So that's my solution. And on the discussion board, you can use the highlight tool to mark that. Now, how do I write this in interval notation? Well, actually, once you write it in graphical notation, it's very easy to write it in interval notation because it's simply a condensed version of the graphical notation. So since I have the interval between negative 4 and 5, including negative 4 and 5, so I'm going to write it in interval notation by opening up a bracket, and then my solution goes from negative 4 to positive 5, and that closes the bracket. So this is my solution in interval notation. Okay, so now let's try the other one, the OR inequality that I'm going to do. So this is a different problem. So this is my OR inequality. So these two, you solve them separately. So here, let's do this first one. 4 minus x is greater than or equal to 1. Okay, so the first thing I do is I'm going to subtract 4. Okay, and then I have negative x is then greater than or equal to 1 minus 4, which is negative 3. Now, here you have to be a little bit careful because you need to remove the negative there. So we're going to divide by negative 1, or you can multiply by negative 1. You get the same thing. This is going to make the left side positive x. But then you have to make sure that you at the same time flip the inequality to maintain the true statement. So anytime you multiply or divide by a negative number, you have to flip the inequality. So make sure you don't forget that. And then, so x is then less than or equal to negative 3 divided by negative 1, which is positive 3. So this is one part of my solution. Okay. Now the second part of my solution is solving this second inequality. So it's 6x minus 3 is greater than 27. So I'll go through the same way. I'll add 3 to both sides. So then I end up with 6x is greater than 27 plus 3, which is 30. So then I'll divide by 6. So I get that x is greater than 5. Okay, so that's my other part of the solution. Now, so my solution is that x is less than or equal to 3, or x is greater than 5. So this is using the inequalities. And now I need to write it in graphical notation and in interval notation. So let's do those one by one. So let's say I put up the graphical notation first. So let's put down our numbers. Let's say this is 3, and then this is 5. Okay, so let's do our shading first. So this says that x is less than or equal to 3. So if we shade all the values that are less than or equal to 3, that would be in this direction, and this would continue forever in this direction. And then all the values that are greater than or equal to 5, well, that's to the right of 5, and this will also continue forever. Now notice that this first part says it's less than or equal to. Okay, so that means 3 is included, and I would use a bracket at the number 3. And here notice it says x is greater than 5, so strictly greater than 5, not equal to 5, so that means at 5 I would use a parentheses. Okay, so that's the difference. 3 is included because it can equal 3. 5 is not included because it cannot equal to 5. Okay, now the question is, how do I write this in interval notation? So in interval notation, how do you describe the fact that this goes left of 3 forever? Well, if you go in this direction forever, where you're going towards, although you never reach it, is negative infinity. And here on the right, where you're going towards, is you're going towards positive infinity. And again, although you never reach it. So the way you write this is that you are then going to go from negative infinity to 3, and infinity always has a parentheses because you can never actually reach infinity. But 3 has a bracket, again, because 3 is part of the solution. And so then the solution is the union, that's what this big U symbol means. It's the union of this interval from negative infinity to 3 and the interval from 5 with a parentheses matching the parentheses up there to positive infinity. And again, infinity always has parentheses. So the solution in interval notation is the union of these two intervals, which are the same two intervals that are shown graphically up here. So I hope that helps you with your discussion problems.